Our last, but certainly not least, presentation in this session is by Maria Arevalo Sanchez, and she will talk about the grand opening of the European JWST Archive at the
Hello to everybody. My name is Maria Arevalo Sanchez. I am a DevOps engineer at the ESAC Science Data Centre in Madrid, Spain. And on behalf of our team, I would like to introduce you today to the European James Webb Space Telescope Science Archive, which is almost ready to enable great discoveries once Webb Telescope is full operating in space very soon. I will give you today a brief overview of the basics of the archive, and after that I will demo you some of the functionalities that we have made available at the European JWST Archive. So why there is an European JWST Archive? As you might know, the JWST project is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. And the main reason for having an European JWST archive is to provide the official European Space Agency repository of all the public data that will be produced by the mission. It is also being designed to be a service to the scientific communities, especially the European one, and this project is trying then to provide useful access to the science data products that will be available once Webb is doing science operations. Being designed and developed at the ESAC Science Data Centre, we have put eJWST data in combination with STScI. STScI is the portal that provides an overview and interface with the astronomy science archives hosted by the ESAC Science Data Centre. The eJWST archive will become part of the set of the observations available to users. This allows the linkage between JWST data and data from other ESA missions, and is an alternative access point to JWST data. In eJWST archive, it is possible to overlay footprints from planned and existing JWST observations on top of images from different observatory missions, including, for instance, Hubble and Spitzer. We have also added custom JWST view capabilities on this exploration feature that the eJWST archive is offering. You can have a look at the poster prepared by Matthias Wonblatt, where you can find extra details on these capabilities. For those observations including among their products, images or cubes, we have also developed our own dedicated data viewers and will be shown in the demo. Regarding the data ingestion, we have tested with data transfers and the simulated data from STScI in April 2019. We also are running the auto-production of hierarchical progressive surveys, the HIPs, and the Hill Peaks multi-order coverage maps, the MOCs, both being the IBOA recommendations. And although eJWST holdings consist of public data, we are also offering the opportunity to access the proprietary data from STScI, which is available in the user interface session and in the AstroQuery sessions using STScI authentications. So proprietary data can also be downloaded and explored in eJWST if the users have the required access credentials. We are also providing access on a TAP Plus REST service. TAP Plus is an extension of the Table Access Protocol, the TAP, specified by the International Virtual Observatory Alliance, IBOA, and the Plus means that the implementation has been extended by ESDC to provide extra functionalities, such as security and user private area, among others. The eJWST archive also has AstroQuery access capabilities. We have implemented an AstroQuery Python module that provides an API, allowing direct programmatic access to the archive. We have also extended it to provide access to resources for running pipeline software and analysis, and we are also working with the European scientific community and consortium teams regarding early mission data access and analysis. eJWST is also providing a Webb Space Telescope area in Data Labs, which is the new science exploitation platform which is developed by the Data Science and Archives Division at ESAC. The Webb area is based in Docker images that are ready to be used to explore and analyze Webb data by using Jupyter notebooks, AstroQuery modules, and STScI. You can have a look at the poster prepared by Marcos López Caniego that will explain you a bit more about this. So let's now jump directly to the demo to see all this in action. So here it is, the homepage to the European JWST Science Archive. From here, we can start exploring JWST data by searching by target name or coordinates, or we can also filter by proposal ID. We have also direct access to the main functionalities of the application. Let's have a look at the search. Here we have a search form for retrieving observations, where we can apply some filters based on coordinate and target name position. We have also some observation constraints, where we can provide some observation ID and list of observations. We can also search by instrument and instrument mode. We have also filters in the proposal metadata, like PI name or proposal ID, and we can also search by observation date. Let's have a look at one of the proposals ID that we know that we have observations, and let's have a look at the right side of the search form, and we have here the current search that we are doing with the filters that we are applying. We can have a look also at the ADQL query that is being done to the backend service, the tab server that is available for eJWST, and we can see the results that we would retrieve with the current set of parameters that are applied to the search. So let's go to search those observations. While you see here loading all the results in tabular results, if we click in one of the observations, we will retrieve all the details for that observations. On the left side of the observation details panel, you will see all the summary of the metadata of that observation, an image preview if it's available to show, and then on the right side we will see an sky view around the target coordinates in ESASCI, and projecting on this ESASCI instance the footprint of the instrument detector that has been used for the selected observation. We can also add several footprints to this results view. So we can add, by clicking on the observation ID checkbox next to the name, all the footprints that we want to add to the view. If they are in the same part of the sky, you will be able to see them all together. Let's have a look at full screen mode of the STScI instance, and here you can see that we have access to all the functionality that STScI provides. The background image can be customized, so you can select another sky and change between electromagnetic fields. We can also overlay some image observations that are available in that region of the sky. Here we see we have some optical HST observation. If we click, we will see what's available to show us in this place. So we can select and retrieve some metadata from these observations. We can maybe overlay some Spitzer ones, and you can see here all the footprints from these Spitzer observations. We can overlay as well catalogs. You can see here, for instance, we have a Hubble source catalog sources to be added. We also have the Gaia EDR3 data to be added to the view, and we also are being able, by clicking on this telescope, to project the JWST focal plane for each of the instruments using this feature. So we can add the focal plane for each of the instruments, and we can move it around on top of the observations that we have plotted in the sky, and this is a useful tool for planning observations of JWST. Let's close these panels. Let's go back to the results, and let's have a look a bit further on some other functionalities that we are applying on the results. So let's have a look at how we could retrieve some data products from the JWST observations. Since we are not logged in, we are not able to retrieve any data or any preview. So you don't have access to any preview, and if you want to retrieve data by using the download products functionality, let's select this level that we are showing here, which is level 3. We see that we don't have access to any of the products, only to one, but the rest is private. So let's do a sign-in action by using the CAS authentication service. And on my account, I have provided a valid token, which is granting me access to private data inside JWST MAST archive. So if I will look for the same proposal ID, let's have a look at the results that we were having a look earlier. So we will see that now we have access to the previews, and we can also have access, and we are able now to retrieve the observations, the product observations to this observation. So we have here, you see they have changed color, and now all the products are available to be downloaded. So this will be requested to MAST. We are providing the token. MAST is saying that we are authenticated and authorized to get the data, and MAST is sending it back to us. So here we can have a look at the image data viewer that we have developed for FITS images, where we can zoom in, zoom out, pan around, etc. And I wanted to show you as well how the cube visualizer looks like. So let's go back to the search, and let me look for an observation ID that I know that one of the products containing it is a cube. So here we'll see a new icon that appears that is telling me that this observation has among its products one cube. So if we click on it, we will see this window, which is composed of two panels. The left panel allows users to explore the images in the cube for each wavelength slice. And this right panel is showing the spectrum across the whole wavelength range of the cube at the location of the pixel that you select. So you select, you will be locking the pixel, and then you can play around in the spectrum visualizer. We are retrieving slides from MAST in real time, and they are available to be explored as soon as they are being retrieved. So this is the classic way of exploring STScI data by searching and filtering by target name, proposal ID, etc. But we are offering as well a visual exploration of the JWST products, including all the heaps and mocks that we are producing for JWST. So this tool, which is based on STScI, is taking advantage of the extended STScI API to create a custom view of the JWST products with a larger level of granularity. We can select instruments and exposure levels, and we can explore within the sphere and check on the mocks and having a look at the JWST observations that are inside it. So if you zoom it a bit here, you will see the available MIDI observations that are available in this part of the sky. Here they are. So we are offering as well an ADQL search interface where you could provide some ADQL queries. And if you are familiar to the Gaia archive, this will be familiar to you. And we are also providing a comprehensive guide of on how to use the user interface, and also how to use the Tab Plus programmatic access, and also some guidelines on how to use the AstroQuery Python module. So this is everything I wanted to show you. So thank you very much. I'm waiting for questions. Thank you.